So for experiment 3 for my digital electronics 2 subject, it is entitled Timer 0 Delay Using Polling and Interrupt. The objectives of this experiment is to demonstrate how to create delay using delay polling and to demonstrate how to create delay using interrupt. So the equipments and components that we will be needing is a PIC 16F18875, a 220 ohm resistor, an LED, breadboard, connecting wires, picket 3 or 4, and power supply. So for the procedure, for the part 1, it is for the delay polling. So what we need to do is, of course, open our MPLAB XIDE app. So open the app and wait for the application to load. After that, what we need to do is click on File, New Project, Microchip Embedded, Standalone Project, click Next, and select a device, PIC 16F18875, and click Next. Click this controller, XE8, and name the project. I'm going to name it Experiment 3 Part 1. Finish. After the simulation is completely loaded and the my config file is saved, what we need to do is here at the pin manager, change this to that. So we'll see the package view here. So here we can see which pin are we going to use. So I would like to use RA7. So here we're going to turn on the output for port A7, and next oscillator select high frequency oscillator 4 megahertz, and this should be checked. After that, what we need to do is go to pin module and rename our port. I'll rename this LED underscore oh no, I'll change it RA7 underscore LED, and I will uncheck this one analog because it's for the output. And next we'll go to we should go to the available resources and add TMR0, add this, and this should appear. And here we should change the value for our timer. So here, these are the values that you should change. This is 250 milliseconds because we want to try it with an interval of 250 milliseconds. And after that, we should generate. After generation is complete, what we need to do now is go to source and open the main C file. Here, this is where we'll put the code. So scroll down here, we're going to type our code. So we're going to use the timer. So for that, let's open all of these files. Let's look for the code for the timer. I think it's here. Let's look for Tmr0 underscore. This one has overflow occurred because when it's will be allowed. So let's type the code. This is for the delay. This is our pin, the custom name there. And let's copy this timer because this is what we're going to use. Here, paste that, and that's equal to 0. Okay. Just clean this a little bit, and now let's generate. After generation is complete, we'll click on build and wait for the application to load. This might take a while, and build successful. To be able to transfer this hex file, we should connect the PicKit to the computer.
Now let us transfer our code to the IC. To do that, we will need our PicKit 3 ICD2. So what we'll do is connect this wire here and this here and plug this to the computer. There. After that, we'll put the IC here. The use side should be here on top. So let's just place it there and lock it. And then let's head on to the MPLAB XIPE app.
So here, what we should do is open the MPLAB XIPE app. Wait for the application to load. So the next thing to do is first configure the settings to avoid errors. So to do that, go to settings, advanced mode, type the password microchip, and go to power. Check this, set this to 3.125, and browse for the hex file. Find the hex file, and hex file loaded successfully, and connect it to the IC. So okay, and then program. After that, programming complete.
So this is the circuit for the delay polling, the first part of the experiment. So as you can observe from the pin manager, from the package view, the 13th pin is our output. This is it, the red wire connected to the LED, resistor, and the ground. And the VDD and VSS, this violet wires is the VDD, and they are connected to the source, and the yellow wires VSS are connected to the ground. And putting a positive terminal here, and this is for the negative for our power source. When I turn on the power supply, you can observe a delay in 250 milliseconds using the timer that we coded. So yeah, there.
So the next part is to try it for 2 milliseconds. So here we should change it to this ratio and this 2000 milliseconds. And also when we generate, and we should also build, and here the main C file, let's build that. build successful. So next is for us to transfer it again. Yes, yes, that. So using our pick kit, we'll transfer it to the IC and programming complete.
Using the same pin configuration and the module, we just transfer the code here, and we've connected it again to the 13 pin, the output, the VDD, the VSS, and everything. Let's now turn on the source, and there, as you can see, the experiment was successful. It showed a 2 millisecond interval using the timer code.
Next is you're going to use the interrupt. So to do that, change the timer up setting to these, and enable timer interrupt should be checked, and change this to 50 millisecond. And here in the interrupt module, this should be enabled, and single ISR per interrupt, and generate after generation is complete. Let's see there, generation is complete. What we need to do is go to the main C file and delete this, for we're going to use the code on the timer. So here at the timer, it's important for us to look for the underscore ISR, and here this is already the code. We're just going to add our pin here, the LED RA7 underscore LED toggle, so yan yung magla-light up. And then also it's important to um, add uh, here we're going to include the mcc.h file. So include mcc.h, and also here at the pin module for the timer, we need to um, click here, and I forgot something. We need to remove this one, the slash here, to make it enabled. And there, wala pa din dapat code dyan. Generate ulit. And when generation is complete, what we're going to do now is wait lang, to just make sure that that's set to that, and the timer interrupt is enabled, and click build. After build successful, rewrite the hex file, program, and let's see the results.
Once programming is complete, let's now transfer the IC onto the 13th pin for our output, the red wire here. So 20, 19, 18, 17, 16, 15, 14, 15. And now let's turn on the power supply. And as you can observe there, the LED turns on and off for 250 milliseconds using the interrupt code. And next, we're going to transfer this IC again here, so we can change the code to a 200 millisecond interval or 2-second interval. So let's go to the MPLAB XIDE app.
The next part of the experiment, we're going to change the interrupt to 2000 milliseconds. So in order to do that, these are the so what we need to do is follow these instructions. Change this to 2000. Clock prescaler is 1256. Change that to 2048, and those generate. After that, this is the updated code. We're going to merge this code here. So to do that, just find what we have to insert to the code. Let's scroll. This is what we're going to include the MCC, so let's click that. We're going to replace this. Okay, yeah, let me just check. Let's click on that, replace that, and also this one, and I think we're good to go. After that, what you should do is um, make sure that this is included and the code is here. So let's edit that or add our code and click build. Yes, rewrite, build successful, and program it to the IC, and let's see the results.
Now let's transfer the code with a 2 millisecond interval using the interrupt. So 2019, 18, 17, 16, 15, 14, 13 for the output. Let's check. Turning on. There, as we can observe, it has a interval of 2 millisecond or 2 seconds using our interrupt code.
For the conclusion, using the application MPLAB XIDE, the functions of delay polling and delay interrupt was observed. Both functions of the MPLAB can be used to light up an LED and input a delay. The two functions only differ in terms of the code. The delay polling has the code on its while loop in the main C file. On the other hand, for the delay interrupt, the code used was a pre-coded statement in the Timer0 code file together with the MCC file on the Timer0 code attached to it. It was observed that the delay using interrupt allowed for the trigger to interrupt when the latter overflows. For the recommendation, before conducting the experiment, it is important to have knowledge in encoding using the MPLAB applications. Possible errors that one may encounter in the experiment are in the coding and configuration of the applications.